حبي أهديكم أغلى ما لدي في ربيع سهر فيها الخير ازداد في ربيع سهر شكرا 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 يا ربيع سهر هيا يا أصحابي هيا يا أحبابي هيا سهر هيا يا أصحابي هيا يا أحبابي.
Assalamu alaikum. I'm Sumaya Umar and you are watching Ikids on ITV. Children out there, are you having a beautiful Saturday morning? Yes! Welcome to our science show where today we're going to be doing lots and lots of experiments with STEM fun holiday program. So science, technology, engineering and mathematics, but all in a fun way. Is that exciting? Yes! So come along, join me, let's go!
هيا يا أصحابي هيا يا أحبابي.
We're here on iKids and we have so many experiments to show you today. So kids, are you ready? Yes! And Shazia, what are you going to show us now?
Well, do you want to see something really cool?
Do we? Yes!
Okay, cool. So if you're ever stranded on an island and you need to take 2 chemicals along, make sure to take the potassium permanganate. That's of course if you decide you can't find matches.
On an island, I don't think we'll find matches.
It's more unlikely that you'll find potassium permanganate.
Children
So,
watching, should they be doing this at home? No. Not
no,
with,
no, not at home.
not at home. You'll have to come to
This is a-
Shazia's
this is a-
holiday program.
Redox reaction that we're going to see now.
Okay.
Ions being.
So what did you put? Potassium
So
permanganate,
that's potassium permanganate crystals.
right?
And here's some glycerine.
Glycerine. Okay.
What's happening? What's happening, guys?
Nothing's happening.
Nothing.
Anything happening?
Oh, let's wait and see.
Let's wait and see. Eyes on it, eyes on it.
Oh boy.
Woo! Woo! Shazia, you're a magician. That was fun. That was so cool. Now we can cook some food on there. Okay, next experiment. Come along, kids. Let's go.
هيا يا أصحابي هيا يا أحبابي.
Shazia and Alia, are you guys ready for your experiment?
Yes, high five, dude. Yeah.
Okay, firstly, tell me a little bit about it because I don't even know what everything is here and what are we doing?
Okay, so today we're going to explore hot and cold reactions, and that is, in technical terms, exothermic and endothermic reactions. Exothermic means that energy is going to be given off. Endothermic means that energy is actually absorbed from the environment to break bonds and thus causing whatever it is to get really cold.
Okay.
So we're going to observe now, right now, we're doing some geysers. So it's going to be
Wear your
fun.
goggles,
Yes.
right? Please
Safety
wear your
first.
goggles. Safety first. Kids at
Thank
home,
you.
please don't try this without your mommy and daddy and rather just come to Shazia at STEM Fun Holidays and do it with her and get all the experience you need and learn lots. Okay, let's start.
Thanks. Okay, so firstly, remember when I said safety first, I really meant it. So we're working with
Safety first.
hydrogen peroxide today, so we have to be very, very careful.
Can-
We've got to wear protective gear. The other day I did an experiment and I didn't wear my gloves and I actually ended up burning my fingers. So
Okay, no, we don't want any burnt
don't want
fingers.
any burnt
Both
fingers.
on. Okay, this is very exciting.
I know, right? It's gonna be
Hot and cold
super
experiments,
exciting.
right?
Yes. Okay, so we've got those on, and now we are going to pour some.
Are you ready, Anya?
Are you excited?
Yes.
Yes.
Do you like science experiments? You do them at home as well?
Yeah, but some of the stuff we don't have. We can do a lot of them.
And it's a bit dangerous.
So later on in the show, we'll be doing an experiment where you can actually use household materials.
Okay.
So, but for this one you can't because these are dangerous chemicals.
So this one, children at home watching, please don't try it at home. Shazia is going to show us a nice one later on that you can try.
Okay, so we're just gonna fill these with a little bit of
What are you pouring in there?
So that's hydrogen peroxide.
Hydrogen peroxide.
But I don't.
You know what it is.
So it's the same stuff that your mums, when they go to the hairdresser,
Yes.
they want to look pretty with brown hair and
Yes.
blonde hair.
Oh, it's like
Then
bleaching your hair.
Exactly. This is the stuff they use.
Okay,
So
then it
obviously
doesn't
not
go
in this
under the line.
concentration, not in this concentration, because then you'd burn holes in your mom's head. So yeah, just careful.
Did it mess on the tablecloth? Is
Yeah.
it burning?
No,
No.
it's fizzing. Can you see?
Yes, it's fuzzy.
Yeah.
Okay. So the end result is going to be what sort of?
So this is a chemical. This is an example of an exothermic reaction.
Right.
So heat is going to be given off, and you'll see the reason why I'm using these plastic bottles is that you'll actually see the plastic bottles warp and bend because they get so hot they actually start melting.
Okay.
So you're going to see that happening.
It's going to come out of the.
It's going to be, yes, and the byproduct here is carbon dioxide. So if you blow out, but not too hard, you'll blow me away. So the byproduct here is carbon dioxide, and we're going to observe how it all gets expelled. And later on, after we do this, we'll see what happens if we actually try and collect some carbon dioxide. So this is, let's see how far we get though.
Actually try and collect
Should we
the
do?
carbon dioxide.
We'll try. We'll
Okay,
try.
okay,
We'll
okay.
try. I don't know how successful we'll be, but we'll try. Okay. And then, shall we do 4 or 3? What do you think? Do you think 3 is good? Okay. Okay.
More explode.
After the last episode, there we explode. There we worked on the last chemistry one that we did. We explored the ideal gas law,
Yes.
and that was expansion of a liquid turning into a gas very quickly in a fixed volume, and so there was an explosion. Here, it's a different chemical reaction that's happening.
Maybe an explosion.
Let's see.
Okay,
Let's see.
okay.
So a hypothesis is what you think is going to happen. So your hypothesis is that there might be an explosion.
Okay.
Let's see what happens. Okay. And we're going to need some potassium permanganate right here. And we are going to need some teaspoons.
Put some. Oh, this looks nice.
So this is potassium permanganate crystals. These are potassium permanganate crystals. Can you see?
Yeah.
It's quite cool. They're shiny. Hey.
Yeah.
So I want you to see what color are they?
Black.
Black, right? So I want you to see what happens when I add a little bit of water
Okay.
to them. Okay, so
Now
let's
are
put
you
some
all
potassium permanganate in these beakers.
Yeah.
1, 2.
Already at home? Will you
Um,
count down?
I want to show you what happens when I add
Are we
water.
counting now?
No.
Okay.
What happens? Can you see the color changing?
It became purple.
Yes.
Oh, purple.
Or like magenta, hey?
Yes,
It's quite cool.
magenta.
Can you see? Very cool. Okay, so there we go.
So this is just the water with the potassium permanganate.
Correct.
Right?
This is the water with the potassium permanganate.
Are we gonna mix this with that?
Yes, in a minute, we're gonna pour these into there. But I'm going to ask Samaya to run away because it's going to be a big explosion.
Okay.
And
Are
and I
gonna
want
be
you
Wear your goggles.
I want you to put your goggles on, and I want you to pour it in. So you do 1 and I'll do 2.
Okay. Okay.
And I want you to stick your arm out,
going from
pour it, pour it in,
Okay.
and then just turn around. Okay. When we get to 0. Okay. So exciting stuff happening here on Ikids. Okay, so are you ready? Are you ready? Okay, so let's count down from 5. 5.
3, 2, 1.
Okay. To see what happened. Was that cool? Did you get a fright?
Yeah. Come back in nice and safe.
Yes, come in.
Beautiful.
So
and
can you see the plastic melting
Melting,
there?
oh.
So it's getting very, very, very
If I
hot.
touch it, is it hot?
It's very hot.
Hot.
And that's an example of a hot reaction. That's an exothermic reaction that we've just observed.
Yes.
And that was, that's drawing as the energy is being given out.
The bottle is actually melting, Charlotte.
How cool, hey?
And that was carbon dioxide that
It
came
was
out.
carbon dioxide with a mixture. This is a carbon-based. It's all over my lab coat. And if that gets on your skin, then it actually takes about 3 days to come off.
Oh yeah. Did you get some on your skin? The
But
signs
it's not.
of
It's
doing
not.
this.
It's not gonna. It's not gonna hurt
Signs
you.
of having a fun weekend on Ikids.
هيا يا أصحابي هيا يا أحبابي.
Dean, Leah, and Danielle, did you learn a lot in the experiments just now?
Yes.
Yes. Dean, what did you see?
Fire.
You saw fire. And Leah, what did you see?
Fire.
Fire. And Danielle, what is that? What was that?
Fire.
Fire. Was it scary? Was it enjoyable? Did you have lots of fun?
Yes.
And Dean, what did you see apart from the fire? Did you see other explosions also? No, you didn't. Did you see them, Leah? On the table?
Yes.
And what did you learn? That what came out of the bottles? Smoke, carbon dioxide.
Yeah.
And did the bottles actually get cold or hot?
Hot.
Hot. Were they melting?
Yes.
Yes. Dean, you liked it? You had fun? Danielle, say hi to everyone at home. Hi, everyone at home. Okay, so we're going to go do some more experiments. Let's go, kids.
هيا يا أصحابي هيا يا أحبابي. شكرا شكرا يا ربي عساك. هيا يا أصحابي هيا يا أصحابي هيا يا أحبابي.
Assalamu alaikum and welcome back to Ikids, where we're doing lots of science experiments. Today we did exothermic experiments and now we're doing endothermic experiments. And Shazia will tell us what that means. And let's get started.
Okay, so endothermic reactions are reactions that draw energy from the environment around us to break little bonds. So there's little bonds between each molecule, and those bonds need energy to break. And so that's why we feel if it's an endothermic reaction, then it gets really cold. So do you guys want to see how it happens?
Yes.
Okay, so these are some chemicals that you won't find these at home, but I just want to show you so you know. So here's some barium hydroxide, and we have
Again, don't try this at home.
ammonium chloride. And what we're going to do is we're going to add.
Are we going to try and feel that it gets cold now?
Yeah, so I just want to show you, if you add some of that, these are both dry ingredients.
What did you put?
So it's barium hydroxide and ammonium chloride,
Okay.
and they're both dry ingredients,
Mixing them up together.
but I'm mixing them. Do you think dry ingredients can become wet ingredients without adding any liquid? No,
No, not at all.
not at all. I'm here to prove you wrong.
What do you think, Leah?
See, look what's happening, guys. It's becoming powdery.
Two powders becoming water. Is that possible?
It's giving off ammonia that I just inhaled.
Smells like stinky toes.
Ammonia actually smells like wee. Sorry. It smells like pee pee.
Can you smell it, girl? No. Oh, luckily.
Okay, so strong. So look what's happening. So we're gonna keep mixing, and while I'm mixing,
Is it pink?
would you like to try your own chemical reactions? Okay, so eventually this turns into a liquid. I'm going to add a little bit of ammonium.
Are they all going to try and get the same? Kids, are you ready for your
So
own
you guys are going to try your own and see what happens when you try to make an endothermic reaction happen. Okay, so
some in all the cups.
what you will need, so this is eventually going to turn into a liquid if I mix it for long enough, but I want you to feel underneath now. Is it hot or cold?
Cold.
Cold. Can you feel how cold it's getting? It'll actually drop to -6 degrees centigrade. So it's pulling so much energy out of the atmosphere around it that it's getting ice cold. Can you feel?
What is it coming? It's to what temperature?
-6 degrees centigrade. So eventually it will keep dropping until it gets to -6, and this powder will eventually turn into a liquid, but it'll take a little while because our quantities are not.
Because of the two reactions.
Yes, because of the one reaction, that the two different the ammonium chloride and the barium hydroxide need energy from the environment to break the bonds in between to form ammonia.
Okay.
And that's why we get that strong ammonia smell, and the endothermic reaction is well on its way, as you can all feel.
And
So
it's getting ice cold.
it's getting really cold.
You want to try it on?
So let's try.
Okay.
So let's try. So what you will need at home for to conduct your own endothermic reaction is these styrofoam cups or paper cups. You'll need some citric acid. You'll need some bicarbonate of soda or baking soda, and you'll need a teaspoon. So for these children here, or these super Einsteins here that are conducting the experiments today, we're using fancy beakers, but when you're at home, you can always use these polystyrene cups.
Okay.
Okay. So what we need to do is, I wonder if you can help me open that one.
Can I open it for you? Maybe. How much should I put of each?
So it's 2 teaspoons of baking soda for every 3 teaspoons of citric acid.
Okay, so I'm going to put 3 teaspoons, meaning of citric acid.
3 of citric acid, 2 of baking soda. Yeah.
Okay. 1, 2.
So let's add 1,
Let's go.
2. And let's do yours quickly.
My mom.
There we go.
1. What's your name?
Are you ready, Mahtia?
Waina. Very cute.
3. We're done with that one. And
1,
oh, sorry.
2. Okay, who needs some
Yeah. And
baking soda on that side?
2 teaspoons of bicarbonate of soda.
Yeah.
Okay. You have?
Who is it in yours,
Hands
my
are gonna
sweetheart?
get tight. Stop stirring,
Do you have?
stirring. Yes.
Do you have citric acid? Okay.
Are we missing something?
So now we're going to add a little bit of water. Here we go. And you need a teaspoon here. Let's
How
add a
much
bit of
water should we
water.
be putting in?
Just a little bit.
Okay.
And
ready?
keep stirring, keep stirring.
Okay.
And I want you to feel the beaker underneath.
Ooh.
Feel it. It's normal temperature.
Ready?
Not too much, just a little bit, just a little bit.
So, honey, would you like some?
Just a little. Yeah. Okay.
What's happening to it? Bubbling away.
Okay, now feel the beaker, underneath the beaker. What's happening?
Getting colder.
Is it getting colder?
Leo, what's happening?
Getting colder.
Getting colder.
Yeah.
Can I feel somebody's honey?
How cold is it getting?
It is getting
Getting
cold.
quite cold. Yeah.
Icy cold.
Sure.
Let's also go down to -6. So this experiment.
No, this one won't go down to -6, but it's a nice experiment for you to try at home
Okay.
for to explore endothermic reactions. So how when certain things are mixed together, then you could actually can get
down.
cold. Yeah. So if you ever need to refreeze your ice blocks at home, get some citric acid and some bicarbonate of soda and stick it in there,
Into your ice block.
and it'll keep it cooler for longer.
Oh, underneath, but then don't eat the ice blocks out, please.
If it's in the plastic, it should be okay if you put it in because it's edible stuff. So, that's fun. Are you gonna try it at home? Yes. Are you gonna all try it at home on Ikids? We love to try experiments. So we're going to see you just now with a new experiment. See you just now.
هيا يا أصحابي هيا يا أحبابي.
So it really did become like from a powder almost into a toothpastey, liquidy, and it stinks, but it's really cold. That is amazing.
It is, eh?
Yes. Okay, so next, what's up?
Okay. So it went from a solid to a liquid. How cool is that,
Yes,
hey?
that is very cool.
Okay, so now we're going to do another common
Endothermic again.
exothermic
Exo.
experiment. And this is exothermic is when energy is released. So we saw earlier on we had these geysers erupting, and now we're actually going to trap the carbon dioxide in soap bubbles.
Okay.
So just use your normal dish soap, and we can pour a little bit of that into, into there. That's our remaining hydrogen peroxide in there.
So that's just
Sorry, sweetheart. Beep, 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 beep. Yeah, it's just
Into the
dish,
hydrogen
any dish soap.
Okay.
And you can give it a good shake if you like.
Good shake.
Yes.
What's happening to it? It looks like cream soda.
Don't drink it.
And then all the bubbles down.
Okay, there we go. So, there we go. Now we are just going to
That
add
looks like cream soda.
the same thing again. So I want you all to step back. Take one step back away from the table.
Goggles, Alia.
So it's not going to
Now we put
blow like how the geysers blew, because now the carbon dioxide is going to be trapped in the soap bubbles. And so we see a different version of the common elephant toothpaste. So elephant toothpaste, what they normally do is take hydrogen peroxide and you can mix it with some yeast, and this is something they can even try at home.
Oh, that's great.
But hydrogen peroxide is not something I like kids to play with. So
Yes.
so with an adult
Adult
supervision,
supervision.
yes.
Okay.
So you take yeast and you mix it with a little bit of warm water,
Right.
and then you pour that into a little bit of hydrogen peroxide with some food coloring and some dish soap, and then the same reaction will happen.
Okay.
Okay,
Let's see that.
so let's see. Have a go. Let's put your goggles on, Alia, if you want.
Are
And
you okay there? Okay, but it won't be so. Will it be very? Should they stand back?
I think so.
Are you watching?
I think stand back.
Stand back.
Stand back.
And you're gonna count us down.
Okay, so when you get to 0, we'll tip it in. Okay, so let's count down. 5.
4, 3, 2, 1, 0.
Okay.
That's lovely.
So it really does look like an elephant's toothpaste, doesn't it?
Yeah.
Okay.
Do you
So
think elephants brush their teeth? They'll use that toothpaste.
so yeah.
Beautiful.
Once
That's
you eat
correct.
it, this had Saibono.
Oh,
Did you do it at Saibono? Now you can do it at home with your dad.
it's fine.
Yeah? Can you touch it?
So you can with a glove on, because it's got potassium permanganate in that will stain your hands. You kids can actually, here's some gloves here. If you want to try it. Oh, this one's these are a bit dirty. Let's use these ones here. There's some here. Let's just put one in a hand,
Everybody gonna try and touch it.
and then you can touch it and you can see how warm it actually got, hey?
Also, it also gives off heat.
Yes, because it's exothermic, so that means that bonds are being formed, not broken.
Who wants to touch it? It's going to be warm also. So tell us how it feels.
So
okay?
feel the foam. There we go.
Here you go. Here you go.
Feel the foam around the bottle. Watch your sleeves. Pull your sleeves up.
It's so cold.
It's cold.
Oh,
Stick your hands in underneath.
It's cold.
Stick your hands in.
In my hand.
It's exothermic, so it should be hot. So you
Inside.
so if you feel the bottle and feel the foam inside,
Oh, it's so cold.
then it's warm.
Yes, it is warm.
You got to go all the way in,
I like a black.
because it cools down very
Can
quickly.
I feel it too? Oh, it is very warm. Yes, it's very warm actually. Okay. That was lovely, and we had lots of
Do you feel-
fun here on Ikids
Come.
today. Thank you, Shazia. Thank
It's a
you for
pleasure.
and everyone. Don't forget to come for STEM Fun Holidays with Shazia, and please join us again on Ikids next week for many, many more fun things to come. Assalamu alaikum, and see you next week.
أهلا أهلا في ربيع سان هيا 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 هلموا إلي أبطال بلادي يا نور عيني بالحب يهديكم أغلى ما لدي في ربيع سان فيها الخير ازداد في ربيع سان شكرا شكرا شكرا